have them. So this is just a game-changing gimbal, I think. I know it's a bit of a cliche to say that, but that's quite new. And it's also other is the ZR10, which you'll see on the Leonard's again. We've got the View Pro, which is I think from the first video. This is the one that I have, the Q30 TIRM, RGB thermal, also has a built-in LiDAR. We've got support for this, again, using a Lua scripting driver. They're quite expensive. And then still work in progress, but there's a Japanese company called Zacti, which makes a number of gimbals, 5 or 6 gimbals, and they use the drone CAN protocol with custom messages. So I'm working on support for that. Hopefully that'll be done in the next month or so. And there's also a number of other gimbals that are in the pipeline. It's a company called Otis, I think, that we're hoping to add support for. And I'm sure there'll be more after that as well. So although we have support for all these gimbals, the features that are available are a bit gimbal dependent. And the reason is that it really is a 3-pronged approach. So we've got the gimbal manufacturers that are adding new features. We're in quite close contact with a number of these manufacturers, and we're telling them what we need. And at least, especially in the case of like Gremsy and C, they're responding relatively quickly with new features that we need. So they build out the features in the gimbal, then we expand our drivers. Sometimes we need to expand the abilities in ArduPilot, and so those are 2 of the 3. And then the third one is the ground station development, which I'll get to later. Anyway, this is a grid which shows you features that we've got for each camera so far, and the plan is to try and get it all green or yellow. So you can see in the case of the DJI RS2, we only have angle and rate control. It doesn't have a camera, so we can't take pictures or video or anything. We can, of course, do the location control. You can point at a particular latitude, longitude, but ArduPilot's doing all the hard work there. For the Gremsy, you can see it's mostly green right down to focus. So we don't have focus control yet, but they're adding that. The second and the last one is picture including location. That's what that means. So what this feature is that, this will be a really great feature for mapping. It means that we'll be able to embed the lat, long, altitude, and attitude of the vehicle into the image, into the picture, and that'll allow us to stitch them together much more easily later. Image tracking or visual tracking, you'll see we don't have any support for that for any of the cameras yet, but I think that's coming this year. Yeah, so I guess you can look at the rest of them yourself. Apologies if I've got any of them wrong. It's possible there's a mistake here or there. It just meant as a guideline, really. I guess one more thing to point out is that they are using different interfaces. So some of them use Mavlink, some of them have their own custom protocol. Obviously, we hide all of that down in the ArduPilot drivers, so that you as a user or ground station developer, you don't need to worry about the differences.
Ready?
Yes.
So is Lua going to be the way forward for most of them?
That is a good question. I think that's definitely up for debate. I think the great thing about Lua is that it allows us, as Trud said in his talk, allows us to add support for a new gimbal between releases. So if we can get all the basics done, all the basic support, available to Lua script, then, even if ArduPilot, say ArduPilot's moved on to 4.6, and this, particular, manufacturer's vehicles are still back at 4.3 or 4.4, they can use that gimbal without having to upgrade everything. So that would be really nice. For example, the View Pro gimbal, I've wrote that in Lua, and I'm having serious second thoughts about whether I'm seriously considering moving that to C++. And the reason is that View Pro has about 80 cameras. And I'm not sure how many of them will, all use the same protocol, but I think Lua is slightly harder to set up. And so if we've got a lot of users of a particular gimbal, I think we should move that driver from Lua to C++ if we can.
So is the reason that you have 80 cameras, you have to have 80 implementation because of slide modification?
We'll have to see. I've only got one camera myself, and it's a fairly high-end View Pro camera. So it has pretty much all the features.
Right.
So I think if I can get all of those features working in our driver, then it will support pretty much all of the View Pro cameras.
Right.
But
I mean,
remains to be seen.
If it is, the issue is like you have to duplicate, the code, basically for one camera
Yes.
protocol. So if that is the problem, we are actually adding some, maybe or
Yes.
potentially adding support for required in Lua, which will actually allow you to include common functions.
Yeah.
So that could potentially make things like this easier, right?
Yeah, so maybe to paraphrase what you're saying, so I think you're suggesting that we couldn't support 80 different drivers in C++ because the flash cost would be too huge.
Right.
So, but having 80 different Lua drivers would not be a real problem because a user would only load one at a time,
Yeah.
typically.
Yeah, and also what I'm saying is the development issues that you have in Lua is basically inability to share common methods among different drivers.
Right.
So
Yeah.
that potentially will be coming in RP as well. That should make it easier for writing drivers like this.
Yeah, yeah. So yeah, I mean, you can always copy paste, but it becomes unsupportable
Yes.
at some
But
point.
having a common method basically, and then you can use that, Lua would be a good thing. But
Yeah.
potentially will be adding that as well.
Okay. Okay, great.
I think we could also work on improvements to the ground station for installing Lua scripts.
Yeah.
And it could be like a Lua scripts panel, what list of the ones you've got installed.
Yeah.
I want to install this from the main repository, what version is on there. Something like that, which behind the scenes, so the underlying functionality is there with the FTP client, but it's just not presented in a way that's really easy.
Yeah.
And I think we could improve that and make it possible to have a applet control panel in the ground station.
Yeah.
Maybe those applets can have their own version as well.
Yeah. Yeah, version, etc.
Version, stuff like that. So they can have their own sort of version and have things like that.
Yeah.
Yeah.
Cool. So yeah, lots of good suggestions there for how to make the Lua drivers work better or more easily. Yeah, I think for now, it's great to have it in Lua as a test case because, like I said, if we can implement all the features that this camera provides in Lua, then we can cover. We've got the bases covered. So, but maybe after I'm done that, we might consider moving it to C++ to make rollouts easier or setup easier. Okay. Right. So next one is mission planner controls. Before I started this project, I had no idea about all these controls that Mission Planner has. People come and, as I'm working on these drivers, I'm passing the people and saying, can you please help me test? And I'm finding that many people don't know. So I just wrote this little slide here to demonstrate some of the actions and tabs that we've got available in Mission Planner to control gimbals and cameras. So on the bottom left here, this is the Mission Planner data page, and we've got the action tab, and there's a little set mount button at the bottom left. Probably most people know this, but in here you can set the mode basically of the gimbal driver or the AP mount library. So retracted makes it usually go to 000. And then you would switch between RC targeting, which means the pilot's in control of the gimbal, or Maveling targeting, which means that the ground station or the auto mode command list is in control. So basically switch between those two. Then we've got the payload control. So this is again on the data screen, you right mouse button click anywhere on one of these tabs, and then there's a payload control checkbox, check that. And then you can control the pitch, yaw, and roll of the camera. And the reset button just pushes it back to 000. Then, of course, if you want to point the gimbal at a particular lat, long, and altitude, you can click on the map, right mouse button, click on the map, and say point camera here. and it should rotate to that location. And you've also got the ability to trigger the camera. Most people probably know that, but yeah, you can take a picture easily. Next is the auxiliary functions. So as Michael said in his presentation, I'm a big fan of this one, and I actually asked for this one to be added because really, now that we have all these controls available for gimbals and cameras, you just don't have enough switches or knobs on your transmitter. So this auxiliary function page allows you to control control the zoom, the focus, take a picture, start and stop the video. Also turn on lock and follow mode of the camera, or sorry, of the gimbal.
Are they just method commands? Just
Yes.
commanding directly into the auxiliary function?
Yes.
List.
Yes, these are the it's a real-time command, but yeah, it sends the do aux function command. And like I said as well earlier, we have about 150 different auxiliary functions that are available on switches. So you can set up any one of them here, and it'll be just like you had a switch. And by the way, everybody knows the difference between follow and lock on a gimbal? Maybe not? Okay, yeah. So I didn't know about it either before I started this project. So follow means that the yaw is, by default following the vehicle's yaw. So as the vehicle turns, the gimbal turns with it. And as the pilot is, say, for example, using the transmitter to move the yaw around, that is all relative to the vehicle's heading, right? So you make it point 45 degrees out to the left, vehicle turns left, it keeps on pointing 45 degrees left relative to the vehicle. The lock command means that it is in earth frame. So I have it set up on my transmitter, the top button on my gear link, you click that and it goes into lock mode, and then everything is in earth frame. And that can be either rate control or angle control. So maybe you're, again, pushing the yaw around, so you push a stick or something all the way to the right, and the gimbal starts turning at 30 degrees per second clockwise. If you're in lock mode, that's earth frame. So again, you don't care what the vehicle's doing. It could be flying an auto mission, making corners and all that kind of stuff. You don't have to worry about that. You're controlling the gimbal in earth frame. Is that clear? Now that lock and follow mode, or the lock and follow mode button that you have, that only applies when you're doing RC targeting. So only when the pilot is in control. Right? The same feature is available in auto modes, but it's done slightly differently. It's triggered differently. Is that okay? Any questions here? So on the bottom right here, I've got a picture of the mission planner plan screen. So this is the mission command list. And in the red, these are all the gimbal and camera controls that we've had for years. So, do digicam configure, do digicam control, do mount control, do set cam drig, dist. These are all there. They all still work. You can keep on using them if you want to. But there's a whole bunch of new ones, which I would recommend instead. So image start capture, that's basically just take a picture. In the future, it actually will have some extra features in it, like time-based triggering. So it's kind of funny. We don't have the ability to say, take a picture every 3 seconds. So people right now, when they want to, take a, do mapping, which is not distance-based, but which is time-based, they actually go and do the setting in the camera normally. You shouldn't have to do that, right? You get what I'm saying? Right? So the image start capture right now, it just takes a single picture, but in the future will allow you to say, I want to take a picture every 3 seconds or 5 seconds. Then you can also set the zoom and the focus. We've got the video start and video stop. Again, the do aux function as well. So you could, if for some reason you wanted to execute any auxiliary switch function, you could do that. And the big one, which is do gimbal manager pitch yaw. So this is the one which allows you in auto mode to control the gimbal in angle. You can do either angle control or rate control. So, 0.30 degrees from north, 0.30 degrees relative to the front of the vehicle, rotate clockwise at 10 degrees per second, pitch at 10 degrees per second. You can do all those kinds of things with the do gimbal manager pitch yaw command. It's got a slightly hard to understand flags field. 0 means body frame 16 means earth frame, I think. Maybe I have it backwards. But something like that. Is that cool? Yeah, okay. So, okay, I guess as a bit of an editorial, this is where we are right now with Mission Planner. It's got a lot of features. They're kind of all over the place. So when you actually try to do it, you actually try to use the gimbal, it's a little awkward. So we've got to improve the ground station. And that brings us to some work that David Sustras has been doing for ground control. And here's a little video from him. Sorry. A little funny, I don't know why it doesn't play. There we go. I don't hear any sound. Do you hear any sound?
How about that?
How about that?
No sound?
No sound?
I think I might need to, just a second here.
Digital sound sources, your local speakers.
Yeah.
Yeah.
Maybe this?
Maybe this?
Just set it to the HD audio.
Should be, isn't that this? NVIDIA.
High definition.
That's it.
Nope.
Might have to do without sound and video.
Okay.
Okay.
All right.
All right.
All right.
All right.
Well, I will, that's a bit unfortunate, but I'll try to do the voiceover.
No.
Right. So yeah, he's testing on the erase. Quadcopter. It's got the same camera that I've got here, the CA8. Right.
Right.
And obviously you can see the live video on the left. And right up here on QGC, there are a number of buttons that you can use to control. This is work is still work in progress, by the way. It's not merged yet to master, but it's getting there. So yeah, this is where you can select whether it's yaw lock or yaw follow. That feature I was just talking about a second ago. This is maybe the coolest feature. You can just click on the screen and it will move to that heading or that angle. That's both. That's in two dimensions as well. It can do this because it knows the field of view of the camera. That is a setting that the user has to set.
Is that only a camera control? Is that changing the navigation of the vehicle?
This is not changing the navigation of the vehicle. This is just for the gimbal. So yeah, you can click on the screen, and the gimbal will point to where you're clicking on the screen. It doesn't need to because it already knows the attitude of the gimbal, and it knows the field of view, so it's just got to be like 10 degrees up and 15 degrees right.
I tell you what, that would be a very small step to actually add in a guide and go to gear mode.
Yeah, I've got a slide on cool feature stuff. It doesn't yet do the rate control, but that is also going to be coming. So you'll maybe click on the screen and then sweep left or right or up or down, and it'll it'll then rotate at a certain speed.
Is that a function of the camera? Some code has been written in that situation.
It's really mostly in
mostly
QGC. So we've got these new controls like that do Gimbal Manager pitch yaw, which exposes all these controls suddenly. And then the ground station can take advantage of it to do cool stuff like this.
That's independent of gimbal.
It could be any gimbal, it could be a servo gimbal. Yeah, so you can see him again pointing here and there. Yeah, he's also, you can also easily change between RC targeting and MAVLink targeting. So back on, Mission Planner, you have to change tabs and to change the mode. He's got an easier to find mode selection button. He's also got the ability to, put it back in center or face 90 degrees straight down. And in this next section, here's the point straight down, I think. Yeah, there it goes. So that's easy to find button to make it point straight down or point at home. And this is how you can do ROI. So it's got a little ROI selector, then you click on the map and it'll point at that lat long altitude. You can also manually type in the lat long altitude. And the next part of this video is just demonstration that the same kinds of features work in auto mode. Again, using the Do Gimbal Manager pitch yaw.
Oh, maybe it's here. I was unmuted here. I'm sorry. Yeah. Yeah, when I was trying to get the video sound working, I unmuted myself. Okay. All right, back to the. Let's get out of the screen. Oh, shoot. Wait. Okay. So another kind of cool thing that we've done recently is the Mount POI Lua script. This is just a simple example of, of just one basic feature that somebody asked me for that we can now do now that we've got all these extra controls. So basically, the point of Mount POI is that it tells you the lat long altitude of what the camera is pointing at, and so the reason it can do that is because ArduPilot, of course, knows the position of the vehicle, it knows the gimbal angle, and it knows the terrain, not just the terrain underneath the vehicle, but the terrain out to as far as you want. So the way that it works is it checks it basically moves out in a line from where the gimbal is and from where it's pointing, and it checks every 30 meters or so to see if it's above or below the terrain. So the moment that point falls below the terrain, that it linearly interpolates between that point and the previous point, and it says, okay, that must be the lat long altitude. So and then it draws a little camera icon on the map. So this is some testing that I did in CITL, and it worked. And also Philip and I tested it the other day at CMAC, and we actually pointed it at a mountain, and the little lat long altitude of the point on the mountain appeared. It wasn't super accurate, but I'm sure it'll get better in the future. If you want to have a look at the script, there's a link to it here. It's in the examples directory for the moment.
Was the lack of accuracy only altitude, or was it lat long as well?
Definitely lat long as well, especially if the vehicle is low. So the very first test that we did at CMAC, it was only about 50 meters away and about 15 meters up. So it's quite a quite a gentle slope. And so that means that if there's any kind of like altitude error or any angle error, it turns into quite a large latitude longitude error. So it was. We'll have to see how accurate it is.
It's a limitation of your measurement accuracy from the gimbal.
Exactly. I actually suspect that a lot of it comes from the gimbal, but I'm just throwing shade there at that point. We don't really know. That's just a guess. Any questions? Okay, so some of the immediate next steps that we're going to be doing. Zoom position. So right now you can control the zoom of the camera, but you can only say zoom in or zoom out. We really need to be able to control the zoom in an absolute sense. So zoom to 30 times, zoom to 6 times. We don't have it yet, but it's coming. Same thing for focus. We can focus in, focus out, but we can't say focus to this many meters or this percentage. We want to send, and just to explain why that might be important, those two things. Just at the bottom, I've got a couple of little cartoons. One thing I wanted to do was a dolly shot. I don't know if you know what a dolly shot is, but it's that slightly strange effect they sometimes have in movies where the person seems to stay put, but the background zooms in or zooms out. I thought it'd be really cool to do that with a drone, and I think it would be possible if we have better zoom control. If we have absolute zoom control. For the focus, you can imagine, I mean, how many times have we tried to film a drone flying in the sky and the camera focuses on the cloud behind the drone and it's all fuzzy. So if we have proper zoom control, then, maybe our antenna tracker, or maybe a gimbal mounted on a rover or something like that could take a really nice clear video of our flying vehicles. We should also send the camera information and camera FOV status Mavlink message to the ground station. So in that video from David, he could click on the screen, right? And the gimbal would point there. That only works when the camera is fully zoomed out. If you zoom in, it's going to sweep far too far. And that's because it doesn't have an update of what the field of view is right now. So that's why we need to add those messages. Also send video stream information. Right now, the setup, say for example, Mission Planner to get a real-time stream of video is clunky, right? You have to go in there yourself and type in the IP address and other things. Some cameras, like the View Pro, tell us what their IP address is for the video stream, so we can send that to the ground stations, and they can just get it automatically. They can get it immediately with no user input required. Also, the camera track point and camera track rectangle message support will be added for the View Pro. So this is where a user could, for example, click on a person in the video and the camera will track that person, or they could select a little square around a house, something like that. And the camera will track that, that object from then on. So we need that support for that. Those are the immediate next steps. There's a lot of other things after that. So this next slide is really just to try and get people thinking. For example, in Robert's Mahoney's speech earlier, he talked about how he treats the camera as a sensor. And I think with these new controls, these new abilities, we can do the same thing. It's all kinds of new cool stuff that we can do. So one of them is visual tracking and follow me. So of course the View Pro can, internally the gimbal itself can already track a person or house, what have you. But there's no reason why we couldn't do the same thing with these cheaper cameras as well. If we had maybe a companion computer which could take that video input stream, do some OpenCV, or maybe TensorFlow AI image processing, and we could achieve the same thing with a cheaper camera. But then, as Leonard was talking about earlier, mentioning maybe we could follow the person, right? We could maybe estimate. We know what angle the person's at, so it's easy to point the gimbal. But now maybe we could say, well, we know that that's Rishabh. He's 1.8 meters tall or something like that. And so therefore he, with this field of view, he should be this many pixels high, but he's not, he's smaller. That means we're too far away. We can move towards him.
We can do automatic inspection on a tower or a building.
Yeah. Also, some of you may have heard of the Open Lander project. So this is a project which uses the Luxonis AI cameras to perform safe landings. Maybe we could do something similar with a regular camera, again, piping the image through a companion computer. How about high altitude optical flow? I think our optical flow sensors right now have a very wide field of view, and they're designed for low level flight below 30 or 40 meters. That's kind of their limit. But what if we have a camera like this with very high, with 4K, 6x zoom, the other one has 30x zoom, good stability, maybe we could do optical flow from a much higher altitude. Maybe object avoidance. Anyway, there's a lot of ideas. I welcome everyone's ideas. One thing we'll definitely need though is a development environment, so that we can test out these algorithms before actually putting them on vehicles. Okay. Any questions on that? Or comments?
Just one comment. I mean, the moment you get into processing vision, right, you really get into the hardware testing as well. And you talk in big your environment, you talk the second environment. What's what are you trying to, if you want to do TensorFlow rhythm and stuff, when you so we ran into this actually with Shell a while ago, and we were trying to get, trying to do VIO for the pilot, and it was just what's the compute environment?
Yeah.
And trying to figure out how that fits into the open source code environment stuff is too hard for us at the time.
Yeah.
It's an art problem.
Yeah, for sure. Philip, do you have an answer?
On that one, there's going to be variables things with video send them by that's what they see on blue little given there is bringing that and sure. Yeah.
Okay.
No, full advantage there's full courses.
Yeah, for those people who were listening in and maybe couldn't hear the questions or the comments, it was really around the limitations of, or the CPU limitations that we've got on our drones, and what do we do about that? And so I guess the answer was we have numerous carrier boards that do allow, powerful companion computers. There's also the HereLink receiver was brought up, I guess, as a possible GPU that could be used or CPU that could be used. Yeah, I'm sure. So. Yeah, obviously the CPUs that we've got on our flight controllers, the real-time CPUs that we've got here are not capable of doing image processing. I think that was clarified when we had the Cube Red presentation. All right, another open question is how much communication do we want to allow / support between the ground station and the gimbal? So one thing that I noticed at the beginning of this project was that a lot of manufacturers were writing new plugins for the ground stations to give the pilots better control of the gimbal. Sometimes they use the Mavlink protocol. Sometimes they use the custom protocol that the gimbal supports. But in any case, they were completely bypassing the autopilot, and it's just straight ground station to gimbal. And I mean that's fine, but it does cause a number of problems. One of them is that it means that ArduPilot can't do all that cool stuff that we were just talking about. It has no idea that the gimbal is there or what it's doing. So there's a whole bunch of things that we can't do that we might like to do. Also, it means that we end up with a whole bunch of different solutions. Like we'll have one for the CE camera, we'll have one for the View Pro. They're all different. That's not a great user experience. So from my point of view, at least, I'd like to have as little direct ground station to gimbal communication as possible. I think ArduPilot can do a good job of hiding the differences in the gimbals, but inevitably, I think there are going to be some really special features of some cameras that ArduPilot will never support, or it'll take us a long time to add support for. And so I suspect that there are some situations we're going to need to allow that communication, and I'm not sure how we're going to do that. Especially, yeah. So open question. We can discuss it now or on a dev call someday. Matt? Yep.
I think we're autopilot and we should remain. I certainly see where you're coming from and trying to provide an interface that would sort of smooth that out. But the reality is, I think a lot of the gimbal manufacturers are all going to be doing their own thing. And I just don't think it's really going to be that achievable to kind of smooth that interface out. I totally agree that support generally, but I think that the UI problem is more than a autopilot problem.
So you don't think we should, you just think we should definitely allow all that kind of communication, but you do agree that we should at least do our best, right? To support as many features, as many basic features as we can, right? In our pilot.
Yeah, it's just, like, a lot of people seem to be achieving a lot of this already. A lot of our customers certainly done this kind of stuff. I'm certainly like not an expert on how they integrate that kind of thing. But it seems to be already being done, so it's just, it feels more like a UI problem, that's all.
Yeah.
The problem with treating it as just a UI problem is then it can't be automated by the vehicle in a VV loss situation. It relies, so I want the vehicle to be able to choose its zooms, choose its focus point, etc., based on data being collected by the vehicle when it's over a very thin tether. So I'm setting it out on a task, which is a vision-oriented task, which it needs to be able to achieve itself. Now, at the moment, I've got one of the cameras that all of the implementation of its controls are in Mission Planner. And Mission Planner can't be running on the vehicle doing those controls. And I'm on a very low bandwidth link back. And I want it to go and gather that data and be controlled from within the vehicle. So if it's only implemented inside plugins in Mission Planner, it completely precludes the types of automation that Pilot is good at.
And also multiple vehicles, like what if you have like multiple cameras that is and what is planned that together to make them do,
We want it at least accessible in Lua scripts, and for that, we have to make it that the vehicle and the flight controller understands and is able to control what's going on.
Is that quite true though? Because a lot of the examples you just gave could equally or arguably better be achieved by an onboard computer.
Only if it's got the implementation, those that tend to be proprietary plugins to the ground station, right? So we've got to have implementations of those which are pliable.
Yeah, completely agree with that. I kind of agree with that though. I think that if we try to do all of this in autopilot for everybody, that gets unmanageable.
Yeah.
Well, we could make the distinction of on the aircraft versus on the ground there. I think you're sort of saying that. The example would obviously be good old solar. The implementation of that gimbal gave a lot of control over how it will work, that it's been working together, but it still uses the companion computer to do some cool scripting and stuff like that. But yes, it was all done on the aircraft itself, so it wasn't reliant on boarding.
A lot of what I've seen is like a companion computer with significant compute power is doing some image processing. And we already provide the books from that to request the autopilot to tell the vehicle where to go. So instead of the autopilot having a camera and stuff, there's another layer on top, which is, we're like focusing on finding the vehicle. And then the companion computer is saying where it wants to go and controlling the gimbal and that kind of thing.
Yeah.
So that was kind of where I was coming from.
Yeah.
So philosophically, it's saying that if you have the companion computer, you can put a lot of high-level functionality there. You can do machine learning, all sorts of things to work out where the vehicle should fly, where the camera should point, all those sorts of things.
Yeah, but there is also that remake mission level stuff that you do, but that's primarily handled at the autopilot. So in that particular scenario, you would probably want to make like camera pointing and all that part of that mission key, which means that control lies on.
Yeah, this is kind of what we talk about basic functionality, where it's all it's scripted and you're not going to deviate from the mission plan, through to something where you want the vehicle to operate a skinny link or tether and operate autonomous stuff.
So maybe I should be both.
I think if we can do both, that would be best. But how do we? We'll then have to provide some kind of tunneling mechanism or something, to allow, for example, a ground station to speak in perhaps the gimbal's native protocol, but over Mavlink. I don't know. Or maybe we have Ethernet. Maybe we can create different channels using Ethernet. I don't know.
Mavlink Gimbal V2 service abstracts that concept of gimbal manager away, so that gimbal manager can do autopilot, and it can be the ground station doesn't actually matter where you put that as far as that is.
Yeah, that of course assumes that the gimbal has Mavlink gimbal controls implemented. Some of them do, some of them don't.
The camera itself doesn't consist of the gimbal manager, so you're talking autopilot or ground station for that manager.
I think you're saying if you have like the autopilot can send Mackay commands to something managing the gimbal, that could be like the onboard computer that then actually does has the driver support.
Sorry, was there?
Continuation, I kind of see it as a piece of history that it's nothing implemented, none of the cameras that you work with that or any standard that anyone had originally. So it was a lot easier to in the first instance to have a companion computer and show a camera manager that would do what the blue roll stuff does. So if you were starting out, you would have the same question you have with your scripts or companions do these kinds of things. What would you do now? Can you rely on the interface? Would you plug it in? Go to your product? What benefit would that give you? So that's
Well, I mean, I think there's definitely tons of benefits for having the autopilot in the loop. I mean, Rich just mentioned a couple of them, giving us autonomous control of the camera. But there's also just cases where, RGPilot has a lot more information. Like the mount POI is just one simple example. Most companion computers could get the train database from RGPilot if they wanted to. But RGPilot's got it right there. For me, it just definitely seems like RGPilot should be in the loop, should be implementing the gimbal manager. But okay, I think that's all right. Is there any other questions or comments on that last one? No. All right, so just if you want to get involved, here are some suggestions. There are a lot of gimbals out there, and my office is filling up with them quickly, but I would love it if others could help me test them. And I've actually had good response in the forums from various users who want to help me test. But more beta testers is always welcome. You could get involved with the enhancements. QGC is looking pretty good, but Mission Planner could be improved. So if somebody wants to help out there, that'd be great. Like I said, there's a couple more gimbal drivers that are planned that I have not even started on yet. If somebody wants to write a camera gimbal driver, I've got a couple of suggestions. If you are a manufacturer of a camera gimbal, you want to have RGPilot support, and it isn't on that first hardware page that I showed, you could send me one, or you could send one to one of the other devs. So far, the manufacturers have been very good about providing hardware. And then there's a whole bunch of Mavlink message-related issues that we should solve. So if you look at these two issues, you'll see a big list of line items that we need to work on. And the last one is just that AI integration dev environment issue that I talked about earlier, piping the video into a companion computer, getting that all working under CIDL. We've got an issue for that as well. So that is it. I just want to finally thank my main sponsor, Eames, who's been supporting me for many years and allows me to work on all this fun stuff. Thank you very much.